Hello and welcome to this tutorial. We're going to be making a bouncing ball. Check it out. It bounces. So in preparation for this, I created two files. One moment. I created done.html, which is this bouncing ball. And I created index.html, which is what we're going to be working with. So as you can see, this already has a little bit of code in it. Our index file, and I have done on the left just for reference. Just so we can do things efficiently here. So index.html is a tiny game engine. As you can see, the whole thing fits in a single page. This is the whole thing. There's nothing else here. This whole thing is a tiny game engine. So what do I mean by this? Well, really your browser is a game engine, and this is just, setting it up and running a few simple commands. There's a tiny bit more here. You see there's 5 lines of CSS, just setting the background colors and centering our div here, our canvas element, which is this. One thing you should know, usually you're going to see this: let canvas equals document.get element by ID canvas. Usually you'll see this. However, this is completely unnecessary because actually every browser has to, for legacy purposes, make this just work. If you have any element that has an ID, it's also put in the global scope. In other words, window.canvas, right? Which is the same thing as this. So that's just something you might not be aware of. By the way, you might be wondering, where's your head tag and where's your body tag? Well, you don't actually need those either, believe it or not. Take a look at this. If you go over to the W3C markup validation service and put in this code, you're going to see that it's actually totally cool. You just get one warning, which is you should add a language, but there's no text on our page, so this doesn't even apply to us. So yeah, no errors and frankly no warnings, because this is nonsense. So yeah, this is actually totally cool. You might notice there's no quote marks here. That doesn't matter. We can talk about that another time. So you can also set your width and height like this, or you can just do it in JavaScript. Again, it doesn't matter. You can do anything you want. Again, here we are. We have a ball, but it's not doing anything. So how did we draw this ball? It's not very interesting. It's not very pleasant. Go read MDN if you want to learn about that. This should really, this should really be, this whole thing should be unnecessary. They should just have context.fill circle x, y, radius. They should have this, but they don't because they're bad people. I mean, they're not bad people. I'm sure they're doing their best, but so anyway, you got to make your own circle function. It's not a big deal. What is fun though is if you forget to begin and close your path. Let me just demonstrate real quick by going over to our done file and modifying our done file so that it doesn't have begin path and close path. Look at this. Blah, what is even going on here? What is even that? If you ask me, I couldn't tell you. I think what's happening is that the first and last circle are being connected, and the whole thing is being rendered as a single polygon. But I'm really not. You'd have to ask someone with more knowledge on this than I have. At any rate, we're going to close this before it crashes my computer. So yeah, if you're using circles, remember to begin your path and to close your path. Traditionally, I ignore circles completely, and I just make a bouncing ball that's actually a square in order to prevent this from happening. But yeah, I thought a ball would look nicer, so we've got this nonsense. Okay, once again, let's go back to our index file, which is the thing we're actually doing in this tutorial. Nothing is happening, so let's make this move across the screen. How do we make this move across the screen? Well, we increase the x coordinate, right? Amazing. Are you amazed? I think we've earned a sip of coffee. That's really good. Okay, now what if we want gravity on this? Then we also need y++, right? So it goes down. But that's not very realistic. It looks like it's floating in outer space like some kind of satellite. We want it to be pulled, you know, and we certainly don't want it to phase through the floor. We want it to bounce, you know, when it hits the floor. Come to think of it, it might make sense to have a floor you can actually see. I've never thought of that before, but I'm going to have to save that for another tutorial. So at any rate, what we want to do is to make this fall down a little faster each frame. So, because what does this really mean? Sorry if this is too small to see. Good Lord. Because what does this really mean? This is the same as y plus equals 1, right? We're going to increment, which is of course the same as y equals y plus 1, right? We're going to increment y by 1. But what if we want this number to increase? Like every frame it'll be a little more, right? So how do we do that? Well, that's easy. And it's easy. We go up here and we have a thing called gravity, right? So for you calculus people out there, you could call this ddy, by the way. You call this ddy. Because this number is the one that changes dy, right? This means delta y. It is the amount that, let's start at the beginning. So this is the x, this is the position, this is the vertical position, the y. This is how much the y position changes in the current frame. And this is how much this thing changes in the current frame. So for simplicity, we'll call this gravity, because most people are not calculus nerds. So let's go over here and then update our code here. Plus equals dx and plus equals dy. In other words, every frame, y should change by what? By the value that represents how much y should change, right? And the same for x, okay? So what happens here? We have an error. Why do we have an error? Oh, because we're stupid. All right. So we've got this thing moving across the screen, and gravity is currently not being applied. So how do we apply gravity? How do we apply gravity? Well, let's do this before. Let's say our dy should increase by gravity. So each frame, our vertical velocity, our speed on the y-axis, you know, this could be called velocity y-axis, right? It's the same thing, dy. It's just a little simpler. Now I don't know if you can see this, but now our ball's path is actually curved, okay? The only thing it's not doing is bouncing. So how do we make it bounce? Well, that's a great question. What does it mean for something to bounce? Well, it means that it should stop going down. So that's the first thing we could do. If y is greater than, so in Canvas, the y-coordinate starts at the top and it goes down. Probably should have mentioned it at the beginning. So this y-coordinate, is equal to canvas.height. So if y is greater than canvas.height, then let's just make it so it stays there. Y is canvas.height, okay? So as you can see now, it stays there. The problem is it keeps going right. So let's add a wall, right? Let's call this floor. We need a wall right and eventually a wall left. So if our x is greater than canvas.width, x equals canvas.width, right? Let's make it so it can't go through the wall, right? Now, this is better, but the problem is it's not bouncing, right? It just gets stuck. It just gets stuck in the corner. So yeah, how do we make our ball bounce? Well, we don't want to set dy to 0, because when you touch the floor, you shouldn't just become a wet rag. You should bounce, because you're a ball. You're a ball, damn it. So, you know, what does this mean? You know, we should change the dy value. So currently dy is positive, which means it's going down. We want this thing to go up, so dy should be negative. But, you know, negative what? Like negative 10, maybe? Maybe. But that's not, you know, it's not realistic, because first of all, it keeps bouncing, and also it doesn't bounce enough the first time. Like, this just doesn't make any sense. So clearly, our dy should depend on how much speed we had when we were going down, right? Because we just want to reflect it. We want to make it go back up. So how do we do that? Well, we want this to be based on itself, right? Which of course didn't do anything because now it's still going down. We just want it to be in the other direction. Now it's negative. Boing. Look at that. Incredible. And of course, all we need to do now is apply the same thing on this axis, okay? So we just need this part to be inversion of the dx component here. Boing. And now the problem is it's going to go forever left, and we're never going to see it again. So of course we need our wall left as well. Now how do we represent the left wall? Well, again, this is our origin point, top left. This is 0, 0. So this is 0 on our x-axis. So if x is less than 0, then we should set it to 0. And of course we keep this. We again want to invert the horizontal speed, the velocity on the x-axis. And now we have bouncing in both directions. How cool is that? And if you want to see a trail, let's make our ball a little smaller. Let's make it, I don't know, 10. I guess that's a lot smaller. Is it? Is this not working? Oh, excuse me. Our radius should be 10. It's going to be a lot smaller. Maybe it should be a little more, 20. And now let's make it leave a trail just so we can observe the beautiful path that this ball takes. How do we leave a trail? All we have to do is disable our clear function. So what this does is it clears the canvas at the beginning of each frame, giving us a blank slate, allowing us to create the illusion of movement and motion. If we turn this off, then what we get is this, which is probably not what we want, but it is cool in its own way, especially since it seems that our we can't see anything anymore because it's perfectly overlapping itself. That's kind of amazing, actually. Why is it doing that? Any physicists out there can tell me this? I guess it might be more of a math question. Why is it doing that? Why is it perfectly going into its own path again? Almost perfectly. You see it doesn't quite connect, but that's kind of interesting. So why is it not perfect? Well, that's, I think I know the answer, but I'll let you think about it as a fun exercise. So yeah, that's all for this video. Got your bouncing ball, and in future videos, I'm going to show you how to do user input so you can actually control the ball with your keyboard and your mouse. And we're also going to do collision so that the ball can bounce on things other than the edges of our world, because in real life the world has no edges, right? So we're going to figure out how to make actual walls and platforms and things like that. So yeah, thanks for tuning in, and that's all for now. I'll see you in the next one.